Hello future engineers, today is going to be a quick tutorial on how to make a lever using our VEX components inside of an Inventor assembly. So what I have here, I've created a little base to work off of so you don't have to see the full process. There is one tricky thing with creating this base though. These bearing flats that I have created here and added onto the C channel, they're not perfectly square with these actual cutouts inside of the C channel. So when you constrain it, you can see that I have a little bit of my left side and the top showing. That's because my constraints, I mated the left side and the top over here so that it fits in that top left corner. Now, if we go over to the other side, the same thing is going to be true over here, but now it's reversed. So it's the top and it's the right. So you want to make sure that you constrain them so that the actual channels of these are perfectly aligned. You can test that by going into your view, going to visual styles and choosing wireframe. You can see that there are no duplicate circles over here. And now you can actually see this is the shape that they give you for the bearing flat to constrain. So you need to make sure that one of the faces is on the top edge and one of the faces is on the side edge, and that they all are lined up like this. If they're out of disalignment, for example, let me just show you. I'm gonna go back into shaded, or I'll shaded with edges. If I go to that last bearing flat that I have just added and I get rid of, say, this mate constraint. If I get rid of that mate constraint and I were to constrain the wrong side of it, and let me go over to assemble, the wrong side of it would be constraining this face to one of these internal faces. If I hit apply here, and now I go to my front, and I do that same trick, you can see that they're out of disalignment, they're out of alignment, they're in disalignment. So if I go to my view, my visual style and wireframe, they're out of whack. And this is not going to work for what we want to do. So I'm gonna undo, let's go back over here, a few more maybe. Cool. So now they're in alignment again. This one should have the constraints though. Oop. Cool. This is bearing flat, not have constraints now. Oh, no, we're good. Just go back. Cool. No, I went too far back. All right, now they're in line, and now it has all the constraints. So once you have your base set up and these bearing flats are perfectly aligned with each other, what we can do is actually the trickiest part of this, or trickiest part to recognize it, what you have to do. In order to get this shaft to turn on this center axis, you have to constrain each end of it from its center point. That's the only place that you can actually grab a center axis on this. So go until you see the little green dot pop up, choose that center point, and bring it to this center axis. You can hit apply. And now we're gonna go over to the other side, choose this center point, this center axis, hit apply, and now we'll be able to rotate freely. Now, if you don't constrain your bearing flats in the same way, this next step won't work, and that's how you'll know. If you try to do a flush constraint on this outside edge and this edge, it won't work if these bearing flats are out of alignment. So I am going to put a little bit of an offset just so it looks a little bit more symmetrical. From the top view, it's a little better, but there we go. That's our first kind of addition to our setup. Now, same thing applies in terms of our alignment to this C channel and this axle. they don't actually have the same size. So we want to be cautious when we're actually constraining these. So I'm going to constrain one end to any end. That's okay. But then you want to make sure that you choose some corresponding sides, such as this side and this side, to really get it locked in. So now I can hit apply, and it's still going to move side to side, so I want to fix that up. I'm going to do a constraint mate between the outside face of my C channel and the inside face of the stand that it's on. Let's see if we can do a little bit of an offset. There's not a ton of room, so I'm going to offset it 0.01. And that looks pretty good. Maybe I can do 0.02. Yeah, that's about even. Now I can hit apply, go back to our standard home view, and we're going to turn this around until we get our lever. Cool. So that is mostly constrained with the lever, but now if you really want to constrain this and constrain its motions, what you can do a angular dimension, make it a undirected angle. You can choose this face and this face, set it to 0, and then you can use some limits. How far do you want this to actually be able to move? Throw in, say, 60 degrees here, apply, see if that's, cancel. See if that's enough. You can see right here, not quite enough to fully restrict the range. It can move 60 degrees in either direction from that. So I would have to tighten that up. So just continue to go back until you get the actual angle that you need for your part. Continue to work on that right there. All right, hopefully that helps answer any questions that you may have. That's it. I'll talk to you later. Bye.